I do.
I remember we tested a lot of things. Yeah, most were
Hello, everyone. Thank you for coming to tonight's Hyperledger Meetup. We have a couple of interesting talks tonight, and we invite you to ask questions, share ideas, share your thoughts, and if you're interested in future meetups, of course, you can talk to me or Tim, who is really talk about that. So thank you. If you have any questions about Hyperledger at any point, and with that, why don't we jump into it? So we have two talks tonight, one from Kiva and one from first up about your developer experience. Oh, I'm sorry. Yeah.
Yeah. It's from the conference room whiteboard.
Hello, everybody. Can you hear us? Can you hear me? Okay. My name is Morgan. I work at IBM, and this is my Twitter, and this is Swetha.
Hi, I'm Swetha. Also work at IBM. Both of us work on the Hyperledger platform. We're going to tell you exactly what we work on, so I'll do that for presentation. In general, we're open source developers. Tech. Our team develops, works with technology. Those are the kind of things that we work on. With that, I'll start.
All right. Bringing Ethereum developer experience Hyperledger Fabric. So what we're going to talk about today, we're going to do an overview of Fabric just to level set with Fabric. Then we'll talk about existing sort of Ethereum practices, at which point we will talk about the details of some internals of the EVM, not internals of the EVM, but how to interact with the EVM in general, and then the design that we're bringing to Fabric to bring the EVM to Fabric, and how that connects back up with how we assume would normally work with EVM and its we'll go to Fabric, and we'll go to Burrow, and then we'll have a nice demo, and then we'll do questions, and hopefully I don't take up too much time, and the demo is really good. Okay, so Fabric, what is Fabric? Fabric is a permissioned blockchain platform. Its focus is more sort of enterprise and corporate because all of the nodes in the network are basically identified. They all have cryptographic identifiers. They all are in the network specifically to participate on behalf of some entity, usually corporations like other corporations, and they don't necessarily trust each other, but they want to interact in a verified way. Fabric has much more granularity than most public blockchains in terms of you can set features such that only certain identities can look at pieces of data or invoke certain contracts or stuff like that. The ability to maybe run a node is set to specific cryptographic identities. And so the big comparison to a public network is this finality of transactions. What that means is in terms of once the block exists and it's on the chain, there's no way to get it off the chain. There's no forking that can happen. You can't advance another chain and then, oh, this is the longer chain, we'll take that one. That's not a thing that happens in this system. There's a consensus on what the block is going to be, and then committed, and that's it. And so, and how is all of that done? That's done through these endorsement policies, which can be something like, company X and company Y both have to have said, yes, this is a thing, this is a true transaction, true block, and then there's a consensus out in the back end that says, yep, we're all looking at the same thing, and we all agree that this is what it is, and then it's put on the blockchain, put on the ledger, and it is final. And so we're going to go through a quick example, and to set the stage here, what we have client would be the user part that interacts with the network, and then the network is really made up of the peers in the ordering service. In our example here, we have two organizations, so we have company A and company B. They both run peers. In this case, we have just one, but it could be n set of peers. And then on each peer, there is some sets of chain code, and if there are other networks, the sets of chain code on each peer aren't necessarily the same, but they do have to have some consistent set of chain code in common to be able to run through a transaction. Okay, and lastly is the ordering service, and this is solely to determine what transactions are in a block and to determine what order that they will be executed in, or not executed, what order they will be in what order the transactions inside of the block will be in when they are finally valid. Okay, so yeah, that's pretty much it. Let's go to the next one. We have, okay, so how does Fabric work? Fabric, when we submit a transaction, what happens is the peer, the client talks to the peers, and it talks to as many peers as is necessary to fulfill the endorsement policy. So if the policy must have one endorsement from peer A and one endorsement from board one endorsement from board two, it's going to talk to both of them. And then it will, at this point, this is when the actual smart contract, the chain code, is executed. And this is the only point in this process when the execution occurs. And so what happens is the chain code will see the world state, will see the current state of the ledger, execute based on that data, and the peer will execute it, and then it will sign it, say, yep, this is the transaction that I ran, this is the input, this is the output, and sign it with its board one identity, and send it back to the client. The client does this process as many times as is necessary to fulfill the policy, and collects all of these endorsements. Then the client will send it to the ordering service. Now, when I say service, that's what I mean. It could be multiple servers, multiple instances, whatever. But the goal is you package these signed transactions up and send them to the ordering service, and the ordering service is collecting them constantly from multiple clients and packaging these into blocks. And that's where we get our blockchain from. We have the block, which consists of transactions. At which point, the ordering service takes the finalized blocks with multiple transactions and puts them in order, puts them in a block, and sends the block to the peers. At this point, the peers take the block and validate that the block is acceptable, and they validate that the interior bits, the interior transactions are valid or invalid. So there can be invalid transactions in a block, and this occurs when the read-write set, which is the values that are read from the chain, read from the world state, and then written back to it, are maybe in conflict. And so basically, the order is what matters. First guy wins, and it'll be valid, and the second guy to touch it or read from a previously changed state will be marked invalid. At which point, once you get through all of the transactions in a block, the block's finalized, and the whole thing is written into the ledger. And it's important to understand that the block can be valid and the invalid transactions. So when you're looking through the ledger later, you have to make sure to filter that out if that's important to you. But the point is that the world state is only updated by the valid transactions. So peers have a copy of the ledger, and they have a copy of the world state, which they basically keep updates and have to run through history every time you do something. Any questions? I'm perfectly happy to, well, let's see. Real quick.
Maybe in your talk, you said that the system could be set so that some people have the ability to see more transactions and others are more transactions.
Sure.
Can those permissions be changed later on such that people can see old transactions, or would that change what the impact activity is?
I have no idea.
Okay.
Sorry.
Thank you.
On the top of my head, I don't know, but my understanding would be you'd be able to.
Okay. Thank you.
Yeah, makes sense. One more.
How do you determine ordering?
The ordering service does it, and it's irrelevant to the conversation other than there is an arbitrary algorithm that does it. Pretty much it's timestamps, but
Timestamps at home,
signatures and other things.
but it could be offensive.
Yep. Again, it's irrelevant to the conversation. It happens, and you have a period in which you accept a block, make a block, and you have the read in the write sets, which is solely written.
So I'm curious, as a business proposition, the transaction, like an ATM, I borrow money and I spend money. The ordering matters, right, in that scenario, because I could be borrowing something I don't have.
Yep.
So I guess what I'm asking is, how
Well,
are
one of
those-
them is going to be invalid. If you don't have it at any point in time, it's going to be invalid. If you don't have it at a later point in time, it's going to be invalid. So if it's within a single block period, it will be one of them will be invalid. And if you're saying, okay, it's real time, I spit out money and I've got to validate it later, that's a totally different. That's your implementation. So we're going to move on from there, I think. Okay. This is the overall set. Client collects endorsements, goes to the ordering service, and delivers them back. So then we get to the thought, okay, well, where can the Ethereum process fit in here? And we can do that by just swapping out the chain code part of it. And so what we've written is a chain code, but that has an EVM inside. And then from the title of the talk, bringing the Ethereum developer experience. Well, obviously the Ethereum developer is not going to do all of this stuff, but you do want to provide sort of this behavior where you can talk Web3, you can talk Web3 is a common library that is a common library that is used to talk to Ethereum nodes as well as Ethereum what's it called? Remix. So we want you to be able to use those tools to talk to the network. So we're going to discuss how we did that. So again, motivations. There's existing EVM smart contracts out there in the world. They run against Ethereum networks, public, private. But again, it's with all of the Ethereum rules. We want to bring those contracts to Fabric deployments and let them basically have all the same Ethereum rules. And also provide a developer experience that is the same as standard Ethereum developer, as far as we know. So as long as everything, you can use the same languages, they compile all the way down to EVM bytecode. EVM bytecode. And then we also want to provide this more interesting part, which is Remix Web3 other tools. So how familiar are we with Ethereum and EVM and rules and regulations? Technical details. Yes, I guess. Okay, so yeah, we'll go over it. I'm going to go over it anyway at this point. So, okay, so important concept to Ethereum is everybody has an account. EOA is externally owned account, and that's basically a user account. User accounts can do a couple of things. They can send Ether, which is the native token, to other user accounts, and they can invoke smart contracts. We're not going to support the native token part because Fabric doesn't have a native token. And but we will support the user accounts invoking smart contracts because otherwise, what's the point? Then an interesting aspect of the EVM is that contracts have accounts. So once you deploy a contract, the contract is actually in the ledger of Ethereum, and it is reachable at an account. And you invoke the contract by talking to it, basically. Gas is another interesting aspect of the EVM, and that is basically sort of a rate limiting effect in that you have a certain amount of gas that you're allowed to spend when you invoke a contract. And again, Fabric doesn't have this concept, so we basically hard coded some ridiculous amount of gas into our implementation, and so any contract will basically should be able to run. The point being, again, this is a permissioned network. You're not going to DDoS your own network. That's the short answer. Anybody who's going to write a contract that takes up resources, you're going to know who it is. It's signed with their Fabric signature, cryptographic signature. You know who it is. There's no secrets. And so an interesting aspect of this transaction rewrite gas. So when you invoke a contract, during contract execution, you may read values from the world state and write values to the world state. The interesting aspect of it is, because of this execute order validate process that we described, when you ask for the value, you're asking for whatever the current world state is. And remember, you can't change the world state until the block has been created and validated. So whenever you basically query a state, you're querying whatever the state is when you started the transaction, not during the transaction. So you may have written data, but you can't see what you've written until the next go around. Ethereum is not that way. Ethereum, you can write to an address and then read back from the address, and you will get the value you just wrote. So we have to sort of finagle Ethereum's idea of the world into Fabric, and we've done that by the caching layer inside of our implementation. If the JSON RPC API is, I've been led to believe, a very common way of interacting with the Ethereum node to interact with contracts, and it's a nice set of APIs. We've implemented some of it. We've implemented enough of it to hook up Remix, hook up Web3, and have success with invoking contracts and running contracts. Overall, though, the inside of it, there's this. The Ethereum is basically sort of a message passing system where you send data to an address and then you get a response. So we'll look at the details of that. The messages are all in this format. There's a to field, a from field, and an input field. So for example, to invoke a contract, you send data at a contract, because we deploy one at a contract's address. There is contract-to-contract invocation possible, but the more important head is the start. It starts with user account, so the user account is the from, and then the arguments to the contract are encoded in the input field. And because the actual contract can have multiple functions inside of it, you disambiguate that by passing the function hash and the arguments to the function. Okay. The other interesting thing is contract creation, and you do this by basically sending the bytecode to the 0 address, and that's just sort of a special address that exists in the Ethereum world, which is, think about when you start your Ethereum, it starts at 0 and goes down. And so the return of this is going to be your freshly made contract address, and you will gonna plug it in to the 2 address and we want to invoke it. You get all the details? Okay. Let's go over. Just FYI. I'm pretty sure that's going wrong. You can let me know it. So we've got 2 pieces. The results of all of this work is 2 pieces. The first one being the EVM chain code, which we're going to go into detail, and then the second one being a proxy that we like to call Fab3 in regards to Web3, because it's the fabric proxy for EVM that implements the Web3 JSON API. So, cool.
Well, actually, if you could go into that a bit more. So Fabric today, when it goes and runs chain code, it fires up a Docker container and runs something in that. So if you put a portal to Ethereum world inside of that thing,
Sort of. You'll see the exact details in like 5 minutes.
okay.
I think you'll be very happy with the answer. Okay. Yes. Is there one? And then, of course, again, Fab3 implements the RPC API because that's an Ethereum API. And of course, you can talk directly to the EVM chain code in Fabric speak, which is basically using the peer CLI tools. But basically, the Fab3 will talk to the EVM chain code sort of for you and translate the Ethereum. So we have here sort of a blown up version of the peer, and inside of that, we can see that the EVM chain code is running. We have that cache that I talked about. That's what the state manager is. And the state manager talks to the ledger for the EVM. And our chain code is a Golang user chain code, which is an important detail for Fabric developers, not so much for you maybe. But we are using the Burrow implementation, which is another Hyperledger project. Not Burrow EVM. And then our Fabric, the standard Fabric chain code API is 2 functions. One's init and one is invoke. And the invoke, you can do whatever you want with it inside of your chain code after the fact. And we've got some special calls inside of invoke to do specific things for us. But the important thing is that the message that you pass in has to have the to field and the input field. And that is encoded into the invoke arguments. You'll notice from is missing. From is basically generated on demand by the Fabric public key for the specific user. So it's automatically shoved in there for you. You don't have to think about it. Yep. And so now we look at the Fab3 part of this, and you can see that we've got the Fabric Go SDK. We'll talk to the chain code API. And then we have the Ethereum server that your user can talk to. Yeah, that's about that. So, for example, flow, user talks to the proxy. Proxy talks to the peer, which has a chain code on it. The peer API talks to the chain code directly, invokes it. Then the EVM will, if it's a invocation, has to remember EVM stores its contract data in the ledger, so it's got to go query the Fabric ledger to get the to get the Ethereum chain code, or not chain, smart contract, the Ethereum bytecode out of the ledger, and then it will run the actual bytecode, it will execute the contract, generating that read set and write set, and again, we end up with a Fabric signed transaction, not transaction, but yeah, we end up with a transaction that goes back to that goes all the way back to the client, and the client can do whatever it needs to do with it, and it will be submitted to the order will make a block, and then the peer will validate or invalidate it to make it. Cool. Okay. So now let's take a step back from this view and look at the sort of generic Ethereum network world. We have a node. In this node, in this just example is Geth, That is just the Go implementation, the Ethereum stuff. It talks to the Ethereum network, and every time life is wonderful. And then we have somebody who wants to interact with this network. We'll use a nice developer tool such as Web3 or Remix, and I can't remember right now. And it will go through and it will talk to the local node, and the local node will talk to the network, and the network will execute smart. Okay, so what if we replaced all of this stuff with the tools we wrote? Notice what didn't change. What didn't change is the developer experience. And so that is the goal. Your turn. Yeah, that's why I'm left.
We're going to try this out. We're going to talk, and I'm going to walk you through the pieces that we did, Oregon, show you the whole workflow. You're going to kind of see it, and we're going to just take basic EVM smart contracts and deploy it on the Fabric network. So let's start off with showing you what I already have here. Let's do that. Can everyone see that? If you can't, now just kind of tell me.
Can you zoom in?
Yes, you can. That better? Okay. Every time I get to open up a new terminal, I'll ask it. If I forget, feel free to raise your hand and say, I can't do that. So basically, this is what I have here is a sample Fabric network that is running locally on my machine using Docker containers. So we have right here 3 + 1, 4 peers. I don't have all the information here because it's too hard to read. So basically, it's 2 peers per org. So there's 2 organizations in this network, and then 2 orgs each. We have a single ordering node, so that's part of the ordering service. The ordering service in this case is a single order. Don't really care about it for what we're trying to show, but I'm just trying to give you an outline of what network, what we're playing with. If you're familiar with Fabric, this is a variation of the Fabric samples, the first network example that they have a tutorial on the docs. The only thing I've done is edit it so that way I can have the EMCC being deployed and run versus the sample one that they have. And then you can see here we have 4 containers, the EMCC, and you can see here they're linked to the peer. So it's 1 container per peer node, and they are running the EMCC. Now that we have that, let's go over here, and I'm going to run our Pod3 binary. So I want to show you what it looks like. Basically, this is the basic information you have here. There are a few things that you need to do to configure Pod3 to be able to talk to a Fabric network. Now, this is kind of different from like a get node, because in get you can literally just type get and it will figure it out and have some defaults for you. Fabric, we don't have a public network. It's not going to work like that. We do have some restrictions and things that you need to follow and link to. So first basic thing you need is a config. This config is, if you're familiar again with Fabric development, they have SDKs that we expect people to use as their client. Those SDKs have a config format that they've already produced, and it's pretty standardized. We're using the exact same thing. It's not too much of a surprise because our implementation uses one of these. This right here kind of is a basic topology of the network. So it basically says, here are these orgs. These are some of the peers that you can talk to. And then the peers have enough information on there. So once an SDK or client comes and talks to them, they have a way for node or the client to figure out what the whole topology is. You don't have to write all of it down, just enough to get started. This is also where you would say where your credentials are, where are what users, what org you are, and that kind of information. And it's kind of expected in a standardized format, but again, these are all standard Fabric things. So if you go through the Fabric stuff, this is not very, it's not a departure from that. From there, the other thing you need is the channel. We didn't really talk about channels, and I don't want to get too much into it, but it's kind of a way to shard the network and divide out what information is accessible. So the channel, you wouldn't know this, but I know this because I deploy my network. This is the channel that I have EVM running on. The next thing I want to do is the org. I'm going to say I'm org 1. I'm going to do my user and do the 1. Now, the other 2 things that you can configure here is We default to EVMCC, but really when you install and deploy that onto your network, there's really nothing to stop you from naming it something else. And it really is unnecessary for us to restrict you to name it a certain way. So if you want to change it, you can. We give you the ability to configure it differently. The default is EVMCC. The other thing is the port. The default port is 5,000. Of course, you can run it wherever you want. It's not going to affect the running of this. So I'm going to do that, and you can see immediately we have started tab 3. It tells you what port we're running on. And with that, let's actually start doing this. The first thing I'm going to do is I'm going to go to remix. I don't know, it doesn't look like everyone is an Ethereum developer, but if you are, this is one of the first contracts that you will play with. It's just a very hello world. I think most blockchain networks have their own version of it. It's a key value store, except there's only one value you can store. And basically you can set it, and then you can get the data back. Very simple. If you're familiar with Remix, the next couple seconds is going to be a little boring to you, but this is a great tool if you're developing on Ethereum. It was a great start for me, helped me learn a lot. The details tab is my favorite part. You have this is the compiled bytecode that you're using. This is what you actually deploy. It has the opcodes that are associated with it right underneath. We have APIs here, so if you remember I said set and get, they're right here, set and get. And it's basically this JSON output that tells you the structure of the contract. And I will show it to you a little bit later of why this is helpful, but it's really helpful for clients, Ethereum clients, to be able to give you abstract away a lot of this bytecode and the hashes and all of that. And this is what we're really using it for. Web3 is a nice Node.js library that helps you interact with main applications. It has some simple code. And then the other big thing that I want us to look at is function hashing. So if you remember how contract invocations work, we need to know that if we're working with raw bytes. So, said a lot. I'm going to go over here. Looks like I already ran this demo once, so I'm going to start over. We're at the JavaScript VM, and you can play, you can run around, and do all the things you want, and test out your contracts here. But I'm going to actually connect, so this is the Web3 provider. I'm going to say 5,000. That's where I'm running my thing. Immediately, you see that the network name has changed to custom and it's Fabric EVM. You have, this is my account address. Now, this is not stored anywhere, but it's generated on the fly. So if you need it, it's there. And you can see 0 ether because, well, there's no ether for this network, and you don't have a token. It's always going to show 0. Saying that, I'm going to just pull it. I'm just going to use this a little bit so we can see, and you can see the block has been finalized. And then we have this contract over here. Something very simple. I'm going to set it. A second. It looks like it happened. I do a get here, and I get 5. Now that's not very impressive because you can do this without a network. Run it into VM. So let's check out what happens on the Fabric side. We go back over here. This is just a container that has all the credentials kind of configured, and it has the peer binary, so I can talk to the Fabric nodes a little bit easier. But I'm not going to do anything too fancy here. I'm going to do peer chain code query. I'm going to pass in the same kind of information I was passing in before. Here, dash thing, I have to name the name of the chain code I want to do, and then I want to pass in my args. This is the args to the chain code. So now you're going to see that we're doing things the Fabric way. And if you remember, the first argument is the 2. So I'm going to just grab the contract address from here. One thing we have to remember is to remove that 0x and x limiter. And then the other thing I need is the function hash. Here, grab get. We do that. This value is going to come out in x. So we do that, and I can see I get 5. Just in case you don't believe me, I can do this again. 10. That I wait for it to change. Do this again. It has changed. Now, this is kind of a neat little demo to show you this works. Let's take it one more step further. And we talked about Web3 a lot. We talked about the JSON API. Those are things that probably people will use more than Remix, because everyone has their own version of how they want to write contracts. and IDs they have. So I have this app. I'm going to show you the app when I run it because going through the code is not going to tell you anything about what it looks like. But the main thing is there's this contract hold.school. I already have it copied in here in Remix. Basically, it takes in arbitrary proposal names, how many ever you want, and then you can vote on those proposal names. Now, one thing to note is this for loop. If you actually try to deploy this on a regular Ethereum network, before it used to not like it because it's a for loop and it warned you like crazy. Things like that are not really a limitation on Fabric because, as we said, we give you a really large amount of gas, and we're not concerned about what functions you're trying to write because typically they're going to be business. We give enough to make sure that your transaction will end, and we also are you have to be mindful whatever you run, your identity is tied to it. It's not anonymous. So you see this in the contract, pretty simple. The application that I have requires 4. It doesn't matter what the names are for this. So I'm just going to type in A, B, C, D, and X. Gotten better and better at taking it out. And you can see it shows up here. Just to give you an idea, proposal 1, 2, and you can see here vote count is really the thing you need to look at. 3, and there's nothing there. Nobody's voted. I'm going to copy this contract address because this is the way I want to interact with it. And then let's go back to our app. I'm going to show us. This is the core piece of code that I think is important for us to look at. First line is line 4. It's the provider. This is basically where's the Web3 provider? How do I interact with the network that I want to talk to? I have it running localhost 5000, so that's where my provider is. You can see we're using this Web3 Node.js library. As you're familiar with this kind of development, a lot of this code looks similar to what you expect. The other thing right here is line 19. I want to change this to the contract address. Put that in there. Remember before I removed the 0x, I don't have to have that problem here. Fabric takes care of how to talk to EVM. You don't have to think about what are the Fabric specific limitations. Fabric takes care of it. You talk how you normally talk. Now let's go a few things just to see how the code looks like. So this is a voting API. This is copied straight out of Remix, and it does similar things. Remember, there's a voting function, and there's a way to query proposals. If you remember right here, those are the 2 kind of functions you have. And basically, once you have this, you can create this kind of voting contract kind of object, and it lets you natively do things like my contract.vote. I don't have to care about function messages, things like that. So I'm a little bit plugging Web3 here a little bit, but this is just in case you're not familiar, and if you are familiar with the Ethereum developer method in a way, you're probably like, okay, this is old news, you're new. It's just kind of an interesting thing, or this is kind of one of the motivations of why we're doing all of this work. And take that. I'm going to, so the only thing I've edited is the contract address. I'm going to start it. Open up. There we go. And we have now our Hyperledger Fabric. You see the logo. This question, we didn't really have a real question to ask, but basically, how awesome is it that you have the Hyperledger Burrow EVM running Fabric? We all really like it and we want it right now, so we're going to say must have now. Submit. Going to start spinning. And then with that, we have a result. And just to show you, we're operating on the same contract. This is proposal 3, and you can see the vote count. So that's basically the demo. So a couple more slides here. Thank you. So we have a few references for you guys if you're interested to get involved or to learn more, use some of this stuff. The first link is our actual repo. This is where all the code is. As we said, we're open source developers, so everything we're doing is in the community, none of it's private or anything. The second one is a blog post. So this is when we first kind of got to a stage where we wanted people to start playing with it and using it. Post through a lot of the stuff that Morgan talked about already. But in case you want another look at it, feel free to look over there. The third point over there is the Fabric EVM channel. So this is where you can contact us. Don't remember email, in the Hyperledger thing. When you see Fabric EVM, you're going to talk to us. So feel free to come over there, tell us your opinions, your feedback, things you want. We actually are having a release planning meeting tomorrow at 8 a.m. If you're interested, please join us. The meeting event information is on the Hyperledger community calendar. And then the last thing over there is the application that I just ran. It's there. It's open source. You can obviously modify it, do whatever you want with it, but it's just a nice little example. With that, any questions? Yes.
What is the interpretation of gas when you're running on that?
So gas is going to be exactly the way it was before. So the EVM is still using gas. It still uses that natively, but the thing is, we've kind of hidden it completely away. We're going to give enough gas per transaction. So as a user, you don't have to think about it anymore. You don't have to worry about like the gas prices, what are the options for running, or some more expensive. We want to get rid of that because it doesn't quite make sense in our permission kind of scenario.
Can Pierre set the maximum gas for?
Currently, no. But if there's enough people who say, this system doesn't work, we want to rate limit some way or the other, and this is how we want to do it, we're definitely open to hearing that feedback, and we will look into what is the best way to approach that. Currently, no one has told us, yeah, this doesn't work. I mean, we get this question a lot. We do get questions like, do you have it? And then when I ask, do you need it? Not everyone says that they want it or they care. They just are interested to understand what's happening. So if you come to us and say, this is what I want to do, this is how I think gas will fix it, we're definitely open to hearing it, and we can make it configurable and figure out what works. I'm sorry.
I do see potential that you have a cyclic graph contracts called contract that would use up eventually the resources of the peers.
So what would happen is there's still a limit. It's not like it's gone. And so there is a limit. So the transaction eventually at one point, you won't be able to call any more contracts. It's just going to end. It's going to be per transaction basis, not per contract usage. So it's there. But if the one use case I've heard that until like they've actually played around and given us like this would solve it, was they want to, even though they don't care about how many transactions or how many things that a user is submitting, they still want them every like 30 transactions to come back to us and ask for more. Like somebody said that. Gas isn't necessarily the way you have to do it there, though. In my opinion, I think it could be as simple as transaction limit, and that might, where that is done, can be in a different place. So it really depends on what you want to do, and maybe we can take this like offline because I think we only have like a minute left. But I'd love to like kind of hear your ideas. If I can.
I think you answered it.
Oh, I answered it. Okay. Cool. Thank you. We will be here even after, so please feel free to come and find us, and we'll definitely look at questions. Thank you.
Thank you to Morgan and Swetha. And as she has said, we will have time after the next presentation. So if you have questions or would like to talk more about that, we'll give you a chance for that. So before we do start with the next presentation, though, I would like to thank Buckshead for giving us the space this evening. And I'd also like to speak for a few minutes as well. So thank you.
So welcome to Quantstep. So for those of you who don't know, we work with security, we do blockchain security, and actually are building a protocol to scale for contract security. So you can start a little video here and a little introduction, and we can keep going from there.
I'm Richard Ma, CEO and co-founder of Quantstep. The reason why Quantstep exists is because smart contracts are vulnerable to hacks, and we make sure that they're safe for everyone to use. In January of 2017, there were only around 10,000 smart contracts. Today, there's more than 8 million. And it's no longer possible for manual human experts to check all of these contracts individually. Constant is really bringing automation to this security auditing industry so that eventually when there's billions of smart contracts, we can still make sure they're all safe.
Here at OneStep, we are on a mission to help as many companies as we can to explore blockchain in a secure way so they can thrive 10 years from now.
To this day, Constant has secured over $500 million worth of smart contracts. Richard Ma, CEO and software developer at Constant.
Yeah, so anyway, yeah, so yeah, we do smart contract security. We look at ways to scale that, especially when you're talking about a public ledger like Ethereum. You want to make sure that what you put on it is safe. And one of the great things about Ethereum is that it is for everyone. So we're trying to find ways like this insurance protocol to actually help users when they deploy something, they actually can mitigate security risk beyond that deployment. So it's kind of like so we call it assurance, but essentially it's a way for backers and stakers to help each other. So if there is some sort of breach or something, there is a way to mitigate that reputational loss of funds. But yeah, if you want more information from us, just feel free to reach out. We're always here. I'll be here at the end. And yeah, welcome to our space. Welcome to Constant. It's a real pleasure to have a lot of Hyperledger people here, and we are actually exploring a lot of stuff. So feel free to reach out. Thanks very much.
Thank you, Jared, for that. Thank you again for the space. So thank you again, and I'd like to invite up next Tim from Kiva, who will be speaking about how Kiva is using Hyperledger to expand financial access. I even do that mouse. You guys hear me okay? All good? Let's see. Well, thank you for allowing me to speak today. I am Leung. I am with Kiva. Today I'm going to give you guys a little bit of a case study. It's not going to be in-depth discussion, but it's really about a case study of how Kiva uses Hyperledger as a means to expand financial inclusion, which is our mission. So I lead the technology team at Kiva. There are about 100 people in the company. We are 25 engineering and it's been after 50 years, so it's pretty aggressive. So, let's keep going. What is financial access mean? I think most of us, it's about how do we access the communities and people in the third world countries that are at the bottom of the pyramid. So it's allowing children to go to school. It's allowing the farmers to be able to buy the equipment to raise the crops, to feed their families, to essentially provide health services for their children. So it's really about going after creating financial access for the low income and impoverished people in the world today. So that's what expanding financial access for Kiva means. So by the numbers, Kiva's been around for about 13 years, 3.2 million borrowers in 85 countries. Our average loan size in microlending is about $4 million. Total lent over the last 13 years has been $1.3 billion in loan volume. There's a loan every 7 seconds in our system. We have 2 million members, 190 countries. The beauty of the microlending in our platform is that the repayment rate is at 97%. That's better than most banks. So you have mortgage bank securities that are lower than 97%. So theoretically, you could yield a pretty high rate of return. But Kiva, currently, we only require our principal back to the borrowers. Hence, we started the Protocol project. It was an incubation in the 2018 at this time. And if you fast forward to today, we basically raised about $6 million in capital to really focus on building out this Protocol project. And I'll talk a little bit about it. So Protocol project is about how do we fund the next billion people in the world. It's about affordability. Smaller loans at this scale are really costly. Credit reports, credit pulls are about, in Sierra Leone alone, it's about $1.30. And if you're only borrowing $100, $1.30 is because it is big spread. So not many organizations actually do this, right? So hence you have huge credit risk. So we want to reduce the affordability of credit, accessibility, infrastructure. There's essentially no internet. You're in the farms. You're barely out in the outskirts of actually any real fiber optics. So we need to build a system that's accessible. And accountability. So credit histories allow for cheaper credit, but what does it mean for accountability? It means that when I make a repayment or I make a payment, I actually should be able to build up my credit rating. Right? And I should be able, once I have a higher credit rating, my risk profile should drop. So that's the basis of really giving these third world countries the ability to access capital. The challenges, right? So when we talk about the challenges of actually creating this credit system, there's financial integrity that's in play. In most third world countries, you have legal regulations in rural areas and poor areas that financial
transactions or it's just ripe for exploitation. You have loan sharks, you have people that are taking advantage of the poor. So integrity of the system is one of the key challenges, right? Second, identity. You can't do anything without identity. In the United States, we have the Social Security number, right? So we can have services, all the services like passports, health services are still, it's based upon the knowledge that we are who we are today, and we can go to anywhere in the world, to any state, and be able to say, well, I am who I am, and people trust me. In the world today, we have 1.1 billion people have no official way to prove their identity. Half of that is in the sub-Saharan Africa, and a third of that is in Southeast Asia. So you have a huge population in the world that actually have no access to capital. First implementation, so we were very fortunate as we were talking about our experimentation with blockchain to run into the UN. We ran in and the UN introduced us to the country of Sierra Leone. So we basically in November of last year, President Bill of Sierra Leone announced at the UN General Assembly that they were going to work with Kiva to build an identity system and to basically latch on, using identity, latch on health services, education services, and also financial services with the identity system. And thirdly, he ran on a non-corruption platform. So it's 2 years in this term. So he's really trying to basically remove the dependence on foreign aid in Sierra Leone by building a system that where you have identity, you create self-sovereignty, you're able to create a access to basically first world capital, because then you assign risk to the financial instruments that are coming into the country, and with that first world capital, you remove your reliance on foreign aid. So that's the president's vision for whether we do this. So he said we're open for business. We have the cooperation of the government, obviously. The other advantage is with the identity system. In the country of Sierra Leone, because he ran on the election, it was based upon an existing ID system. So within the country of Sierra Leone, they have population 7 million. They have identity for 5 million people. So and it's sitting in the national registry, it's sitting in a national database. So it's actually primed to basically with a blockchain identity system. So we're in the process of doing that. Banking partnerships in the country of Sierra Leone, there's only 2,000 people that actually have access or are borrowing enough money to warrant a Bauer 30 credit score. So there's only 2,000 people out of the 5 to 7 million citizens that actually are able to take out loans. So we have banking relationships that we've established. They actually want to do this, right? They actually want to put the payment history, they want to build a general ledger, they want to look at the data, share the data, so that when an individual comes into the bank, they actually know their risk profile and be able to loan appropriately. So we have banks that are interested in doing this, and we have partnerships with not only the banks, we have microfinance providers, we have eco-bank systems that are actually going out into rural areas, basically go out to reach out to the farmers, do the application process with the farmers. So it's basically a really large government outreach to do this. So we picked Hyperledger. We're using Hyperledger Indy for the identity system. We're using Fabric for the credit system. So in the process of a loan application, so I'll walk through some of the steps. First step is basically a citizen walks in, biometrics, fingerprint scan. The fingerprint data is actually in the national database that I talked about. So we're building a system so that they'll be able to do a fingerprint scan, verify their ID, fill in the application, get the ID, get the credit pull, and then once you have the loan, you basically or as you pay back on a monthly or weekly basis, it goes into a blockchain ledger. So why Hyperledger? This is actually a real picture. I was actually in Sierra Leone a month ago. So this is actually a picture of a diesel power generator that's sitting on the dock of Freetown, augmenting the power in the country because there's so many blackouts. So you have electricity, goes in and out, and this ship has been providing sustainable power for the country. So sovereignty control, that's the beauty of Hyperledger. So the fraud and deception that I talked about, it's just rife in the developing markets. We need to basically ensure that the citizens have sovereignty over their data, and we need a permission framework that basically allows them to be able to define who the trust anchors are. So we can basically put a permission structure that we know who's trustworthy and who's. So the separation of identity. So what Kiva is doing is that the identity system that we're using in India, the separation is the credit measure. So we want to be able to have the credit ledger separated from the government provided data. The government provides the identity and the identity. We, as individuals or the citizens, basically are uploading for their credit history, their payment history. That is their data. So we want to create that separation that the government doesn't have. So how do we create trust and authority? So we're focusing on biometrics at the moment. So fingerprint data is prevalent in Sierra Leone, but it could be other biometric data as we go to other countries. So biometrics for the borrower. The lender also has to go through a biometric system. So now when the two of them are verified, then the writing to the ledger is approved. So that's how data is basically entered into this general ledger. Here are the scenarios that we're working with, right? So in this system that we're trying to build, these are the four primary use cases that we're trying to solve for. A minority population, it flees an oppressive government. They basically have to rip up their passport, leave the country, go to become refugees, right? And then when they reach their destination country, how do they basically retrieve their identity and basically start their lives over? So this system allows them to do that. Immutable credit, that the distributed ledger prevents the government from basically changing or accessing that record without the permission of the individual. Accessing credits. So once you build up your credit as a citizen, you can actually leave the country, go to migrate to another country, give access to another lender, and they can basically look at your credit and say, "Oh, you're incredible. Here's your risk." So now you can basically build on the momentum that you've established by leveraging your existing credit history. And with people there, that's just another way of setting a readable record. So, but we just don't. We basically, as part of the system, you don't want to a system that where the government, if they're overthrown by a bad government, to basically ask us to change the records. So for Sierra Leone, we started the project at the tail end of 2018. By April of this year, just actually a week ago, we're able to access the 5 million records in the national ID database. We are actually, as we building the individual wallets for each citizen, we're going to basically build on a one-by-one basis as they verify their identity. In a couple of months, we're going to basically integrate with a couple key financial institutions where a citizen can actually walk in, do a KYC, do a customer check with biometric data, and then as we go into the tail end of this year, once they're approved on loans, their ledger or their repayment gets written to the blockchain. So beyond, so we were just in the building phase in 2019, and then for 2020, we hope that there's enough repayment in 2020 that we can actually start to generate credit reports, building a credit bureau for the country, and then the plan for Kiva is to basically build it in such a way that we would use the existing infrastructure, help the citizens of Sierra Leone to build, to basically take the system and make it self-sustainable, so that the credit holders that they're charging now about 34, they can drop to a reasonable rate where that fund to basically fund the staff, the infrastructure, and the equipment necessary to maintain the system, while Kiva maintains more global ID and general credit. Now, that's the goal, and we hit some interesting milestones, and so far we're good. Now, the realities and challenges of deployment. Many of basically all the borrowers don't have computers, they don't have smartphones. There's just limitations of biometrics. So even the farmers today, they work. Fingerprints change because of injuries, scratches. So we still need to overcome this with various other forms of biometrics. Delay tolerance, that's essentially the network latency, right? So we have to build a system that where the banking official or the banks go out, field partners go out, take the loans, collect the dollars, the devices are mobile, they come back to the Wi-Fi or whatever available, and the system can sync with the ledgers. Data access, currently, the legal restrictions are such that the government owns the data. So in most countries, third countries, the country owns the citizens' ID. Primary education, the banking system is basically not digital. Credit records are stored in index cards. If we're lucky, they're in Excel spreadsheets. So there's a whole set of migration process. So you can see the rollout of challenges of the years with Sierra Leone, but most countries are going to be with this. So what do we do? Working with the government data, in order for this to be successful, we definitely have to, this solution has to be a cloud distributed system. We built a hybrid on-premise solution in Sierra Leone. There's a data center that we have built out. We basically developed Postgres extensions to basically optimize the storage of wallets inside of data centers. We basically put in our own servers as part of the hybrid infrastructure to store the credit part of the data, so the government is not building on machines. So we're working with government to get an infrastructure that we have. Biometric data, we're starting with fingerprints, as I talked about, but that's going to get aged out rather quickly. So we're looking for once there's national IDs we can use as the citizenship gets more sophisticated, passwords can be put in place. We use third-party authentications. Third-party authentications is really a way to say if you're in a village, there's 3 or 4 trusted villagers. If they can identify you as Mohammed, you're Mohammed. So that's how the system is going to have to work with that data. key ownership as citizenship get more advanced, and basically have ownership and control of their private keys. Going forward, ideally, as I mentioned, a top 30 for credit bills. If we get it down to maybe 20 cents, that's ideal. And then if Kiva can sustain a nickel, then we can sustain building a network, and the remaining profit can basically go back to the countries to create the sustainability. Broader rollout, where Sierra Leone is the first, that's our example deployment. And we hope to be able to sign the rest of the I think there's about 80 countries that are in the state, so we'll be for the rest of them. And then migrant solutions, everybody, by deploying these services in a cross-border way, as one citizen goes from one country to another, they can put these services with them. That's really good. It's a plug for Kiva. As I said, I'm hiring somebody to go into the team to talk to me. We are a nonprofit. However, we've changed our account structures where engineering and product are actually marketed towards for-profit companies. So this is we rely on donor dollars, so we have a lot of support within our team. One of the key investors of this is Repakula. We have a huge base of support from our operations. Questions?
In terms of securing against government, I look at South India as an example with roll out the Aadhaar card and then demonetization to try and get rid of corruption, dark money. Does the government of Sierra Leone have the ability to look at transactions and see where money flows are, both from a anti-corruption standpoint, but also just from getting better economic data?
So the short answer is maybe, because we haven't built that system yet. But I think the system that we're referring to, like in India or even like China, is really building a system.
China,
yeah. Right. There's the white side and there's a dark side.
Yeah.
So I think so we're trying to stay on the right side. When we talk about self-sovereignty, we really want to, we're pushing the edge of basically allowing the citizens to own their own data. And the government, yes, they own the initial bootstrap of the identity, but once the citizenship gets more sophisticated, they have a phone, they can store it in the wallet, they take the phone away, and they get out of the country, and you're back onto the Kiva global network, and you're done. So I think that's the principle behind it. Now, and this is why we're building a private network, a permission-based network. Our goal is to not allow the country or the governments to basically get access to the citizens' private data. And as we talked about, like the credit is separate from identity.
So can you talk a bit about the revenue model? You talked about taking the cost basis for these credit bills down to a nickel each. There's 5 million people in this country. Let's pretend that 20% of the credit bill every year. Your take on that would be, right? And that's enough to run the machines and hire people. If you just run it for years.
Hopefully, I mean that, but it's going to be not just Sierra Leone, right? So you have country 3, country 4, country 5. So there.
You have an international staff.
Explain a little bit like where the tiers installed and the context of making more credit available to borrowers.
So I think so. The question was about how do we incentivize peers to grow, right? So I think because we're focusing on these global deployments, our biggest ask as we go into the country is that each country creates a node. So it becomes a peer of the Kiva network. And we're hoping to do language actually for that node as well, so that as each country gets involved, their identity system is part of that. It's part of that node.
Now, I'm wondering, one of the great things about Kiva is when you are a donor or owner, you get to see who's borrowing, and actually select who's borrowing, and you get feedback from them, mistakes and what. Are there some mechanisms here for that side, for the funder side?
I think you're right. Right? So currently, if you look at Kiva.org, the marketplace, right? My wife's been a member for the past 8 years, so she actually sees the connection to the dollars. I think it is our goal that we retain that type of connection for the individual lenders. Now, if we're able to create an infrastructure where we have credit ratings for a majority of the citizenship in a country where they want capital, this model really is for a impact fund or maybe Rockefeller or Gates Foundation, basically throw in $5 million of capital or $10 million, and they'll throw that in, and then that capital could be used to target towards each individual lender. Now, going forward, if this scales, you can see the marketplace, the current Kiva.org, and this is starting to know, and you can actually think of it as a lender. I know the risk rating of Ken or Andy, and I'm basically okay, I'm going to get that, a 5% rate, right? Or I can forego that rate and donate it, make it a donation. So now you have the ability to kind of make a risk analysis. But that's the real goal, is to basically be able to really isolate and define the risk. So when you have a repayment rate of 97%, you actually can generate revenue and make it sustainable.
You see, like the Gateway Stadium now, impinging on your business when you fly below the regular.
Yeah, it's really hard to fly below KYC. I think Kiva's been around for a while. I've only been here for 1 year, even that 1 year. We're in the forefront of all these laws. So I think we have about, thankfully, we have a lot of legal support. Yeah, I think we're going to follow really already.
So you said that Venezuela trust anchor was seeded by the government, and I'm assuming that would have allowed you to issue, say, custom DIDs based on the citizens. And so how does that work? Like, you just take all the data that the government has and create digital identities for them, or is it on a per user who signs up these?
So what we would do is we would create the DIDs for them. So the use case would be that as a citizen, I've already voted. I have a voting ID, I have a national ID. I may not know what they are, but as I go into a registry, the CRA, I can thumbprint in, and they can verify that I'm 10 young. And then once I basically acknowledge who I am, then the DID is created, it gets pushed out, and I should be able, if I was computer savvy at that moment, I should be able to take that wallet with me and put it on my phone, right? If not, I will eventually figure it out. Even my children will figure it out. But that's the premise.
But is there a workaround? Like, what if the government says no to CD or database? Like, if the government says no to give you access to this data, and you have to set up a trust anchor, how would you work around that?
So what we're doing is that we have the data still resides with the CRO now. It's sitting in the Oracle database, and what we're basically syncing that database with our system, and when they submit it verifies that we actually connected to the cloud and we create the wallets in the cloud. So at that point, the government actually can't have the line control over the wallet. But as a citizen, I'm not sophisticated enough to get that wallet right now. But when we get critical mass, they will learn and understand. So the government actually at that point, once your wallet's up.
Is the wallet just for ID or?
It's basically, yeah, it's not even, you can put anything you want into it, right? You can actually put your ledger into it, or you can put the reference to your credit ledger into it. And you can, and I think we're working with the countries here, we want to actually help them not, so we're focused on the financial ledger, but they want us to help them integrate their health records and their education background into the system too.
One question, why did you guys choose
I think it was, the reason we chose Sierra Leone was more that we chose each other. So as we were talking about blockchain, we were experimenting with it. One of our business development executives, he ran into somebody in the UN. We talked about what we were doing, and then we geared up towards, we linked up with actually one of the directors of the Sierra Leone's equivalent of their CIO. He went to MIT. He's the nephew of the president, and it just started, all the stars just started aligning. They have a national database with a perfect integration point. So it just started really aligning. So we got lucky.
Thank you. Again, if you have additional questions, we still have space for about 10 or 15 more minutes. Please feel free to grab them. Also, if you have questions about Hyperledger, I'm happy to help answer those. And if you're interested, there's a few Hyperledger stickers on the back table right there. You're welcome to help us out as well. So thank you for coming.
And if I ask, you can pull up the chair. I guess maybe just stack them against the wall here. Right. And that'll help out our host.